everyone, welcome back to my channel. Today we'll be solving another Leetcode medium hard problem. I don't know if it's really medium hard if I can solve it, but yeah, let's get started. So the question we're solving is from weekly 480. And before we start, I wanted to say that on some days I explain problems better than ChatGPT. Let's see if today is that day. So the question title is minimum moves to balance circular array, and you can pause the screen to read the question properly. So basically we're given a circular array balance, and each element in the balance is the net balance of a person. And so we have the concept of transferring the balance. So each person can transfer exactly 1 unit of balance to either their left or right neighbor, and we need to return the minimum number of moves required so that every person has a non-negative balance. If it is impossible, return -1, and you're guaranteed that at most one index has a negative balance initially. So this is the most important part of the question, that at most one person has a negative balance initially. That's it. So let's solve the first. Let's look at the first test case so that we can arrive at the solution. So as you can see, the first test case is when the balance array is 5, 1, -4 and output is 4. So the one important thing to note here is that the balance is a circular array. That means in a normal array, the indexing goes like 1, 2, it's linear, right? So for each element, if you have this element, the right element is always the farthest, like you just measure linearity and the distance in this direction. But when it's a circular array, then basically after -4, it means the same thing as having 5, then 1 again. So it goes in a circular manner. So instead of visualizing the array as a linear sequence of elements when it's a circular array, then we can think of it like this. If we visualize a circular array this way, then we know from 1, if we go towards the left, then we get 5, and if we go towards the right, we get -4. But you also notice that 1 is 1 unit distance away from 5, but at the same time 4 is also 1 unit distance away from 5. So that's the difference between a linear array and a circular array. So when we come back to the problem, to the test case that is given here, so our balance, we initially start with 5, 1, -4, right? So now our objective is to make sure that every person in this balance array has a net positive balance. So net positive also includes 0. So the fastest way that we can make -4 0 is we can do it this way. First we have 5, we take the second person and make the second person transfer 1 unit from him to the right to the third person, right? So what will happen? This will become 0 and this will become -3. And this is allowed because, like I said, 0 is part of the 0 is allowed because it's still a net positive balance. We want a net non-negative balance, sorry. So now this costed me 1 move, and now I can take 1 from the first person, so that would become 4. This would still be 0, and I transfer it to the left of 4 of the first person to this side, which is to -3, because like we discussed, it's a circular array. So it will go to the third person, and this would become -2, and we kind of repeat this until we end up we repeat this twice until the -2 becomes 0 as well. So this would become 2, 0, 0. So this again costs us 1 move, and then we repeat this move, the same thing, twice. So the answer is the total of the sum of the moves, which is 4, and which matches with our answer, right? So if we think about it, the intuition of it, at least it came to me from the representation of the circular array. So if I consider any circular array. And also, like I said before, the note is very important here. So I note that index or that person who has the negative balance, and this is the person over here. Now this person needs to be transferred the points from the balances of other people from either left or right, and whether it comes from the left or whether it comes from the right doesn't really matter to me, because what actually matters is the distance, which directly translates to the number of moves, right? For example, if I'm doing it like to the immediate left and right of the negative index, then I will exactly use how many ever points I'm transferring to my negative index balance person, right? I would use exactly that. The cost in that case would be equal to the number of units I'm transferring over here. Okay, but if I was not doing it from the immediate left and right, and I move like one extra index away from left and right, so it becomes like a left L plus 1 and R plus 1, then I would how my transferring would work is, first I transfer from the L plus 1 index to the R plus 1 index. So first I transfer from L plus 1 from the L plus 1 index to the L index, and then to my negative index, which we can call as neg or n. So in this case, the cost would be 2, because you are doing like 2 hops to transfer each unit. Okay, so this is the basic intuition. So if I clear up the mess, and I go in the directions of L and R, and then this can be like R plus 1 and L plus 1. So the intuition is clear that we should only consider moving the index towards this side to farther away from the point that we're considering from the negative index, only if we are still not able to compensate from the nearest points. If my nearest points are enough to compensate, then I do not have any need to go for these. So it's a greedy approach, because we first consider those balances that is nearest to the point. Then if that's not enough, then we just go to the next nearest positive balances. So in this case, we only know that there's only one negative point. So it would be like you're just checking for all the distances until it's enough to compensate for the negative balance in it, and this becomes 0, right? So it could kind of be viewed as like we're going to through like this consecutive circles this way until the magnitude of the values at these ends is, sum until this point is more than the negative balance over here. So obviously the edge case is when the sum of the entire balance array, the sum of this entire array is less than is negative basically. So in that case, then we know that we will not be able to ever compensate for the negative balance. For an example of that can be like we have 5, 1 and you have -7. So in this case, the sum would be -1 and that's less than 0, and we will never be able to just use 5, 1 no matter how many moves we make to make the person with a net negative balance to have a non-negative balance. And it can also be the case that we do not have any negative balance at all in the first place, right? So we can just have an array like this, and that we wouldn't need any number of moves to make it. We wouldn't need any number of moves to make it net positive because it's already net positive. So these are the two edge cases, and whatever I've shown you, the approach over here is the solution. So now we can take a look at the code. Okay, so we are given balance, which is our only input, and we need to return the minimum number of moves, right? So the first thing that I did was I found neg index, which is the index of the element which is negative, right? So like I said, I checked for the two edge cases here. When the sum of the entire elements in balance is less than 0, then it's never possible for us to make a net non-negative balance for everyone. So we return -1. And if negative index is 0, I mean it's an empty list. I'm using list comprehension over here. So if it's an empty list, that means that I'm not finding any indices with negative elements in balance, and I don't need to perform any operations. So I again early return 0. Now I assign negative index to the actual negative index from the list comprehension, which I calculated. And like we discussed, this is a circular array. So every computation that we do to the indices becomes mod n, where n is the length of the balance array. So that is just a property of the circular array, and you can think more intuitively about it on your own, how it actually works, how mod works in this case. So I start with a variable cost. I initialize it to 1 because, like we discussed, we need to start with the immediate left and right indices to the negative index, right? So that's what is L and R, and that's why cost starts with 1. And then I hold the current balance, which is the negative balance of at that index, negative index, right? And I'm also having my answer variable, which is moves, which is equal to 0 in the beginning. Now my stopping condition is until my current balance is less than 0. When it becomes equal to 0 or greater than equal to 0, basically we stop, because we don't need to perform the same transferring operation anymore, right? So what I'm doing is I'm saying moves, I'm incrementing the moves based on how much exactly points that I'm transferring from either L and R to my current balance. So I'm taking the minimum of the sum of the balances at left and right indices and the current value. So if the current value is lesser, so basically if the current value is lesser, the absolute of the current value, the current negative balance is lesser, that means that I wouldn't need all of the points from L and R, right? So I would just need exactly those. If it is greater, then that means that I would need to keep going. Basically, my current balance will not be non-negative in this turn. So that's how this works. And I'm multiplying it with the cost so that I am basically counting the number of moves, right? So I'm incrementing the moves in this turn. And then my current balance would then basically my current balance would then be so how many ever points that I'm transferring from my left or right indices, which is nothing but the minimum equation that I have here, right? So how many ever points that I am transferring, I add them to my negative balance so that my negative balance is now lesser negative. I mean, it's more in magnitude. So after this turn, my cost should increase by 1, because then we would be moving the left and right pointers, the left one to one more index left and the right one to one more index right, like as shown in these again mod calculations. And yeah, so when the while loop terminates, that means that the current balance is now greater than equal to 0, and then we return our answer variable, which is moves. And this solves the problem in 67 milliseconds, which is basically O of okay, it's harder to estimate the time complexity of this. Let me pull up the variables of the question. So I'm basically iterating and I'll be in the while loop until and unless my balance is non-negative, right? So my balance can at most be 10 power minus 9, and my balance dot length is 10 power 5. So the highest negative balance that I would need to compensate is 10 minus 10 power 9. And it would also kind of depend on the magnitudes of other balances when there's minus 10 power 9, right? So I'll keep iterating. Yeah, it would just be O of n, because I would keep iterating through all the elements except the negative index, through all the possible left and rights. So it would also be like O of n by 2 until and unless I find that I've compensated for my balance. So basically the sum of all balances at the left and rights that I've seen so far, I would have the sum would have been greater than my negative balance. So yeah, so this is the solution that I came up with, and I hope that my explanation made sense and you've learned something from this. Thank you. If you made it so far, please consider subscribing to my channel. So yeah, it would motivate me a lot for the next DSSA videos that I may make. And if you have any comments for what type of videos that I can make that you would like to watch, then they're always welcome. Thank you and bye.